Hey everyone, welcome back to Rock the JVM. This is Daniel, and in this video, we're going to talk about the Finagle RPC library for the JVM, obviously in Scala. And for those of you who've heard of Finagle, it's one of the core libraries behind almost every service at Twitter, which is one of, if not the, largest Scala codebases in the world. Now, with the recent chaos happening at Twitter in recent weeks, I thought I'd record this tutorial for you to understand how intuitive and powerful this library is. Now, as I'm recording this video, I've heard that the old Finagle team at Twitter has resigned, which is kind of bad news, but because Finagle and Scala are such a core part of every piece of tech at Twitter, I have big doubts it will cease development or that Twitter will be rewritten to something else. So I do expect this tutorial to still be very relevant, maybe even convince you to add your own contributions to the library as you understand how powerful this library is, even if the old maintainers have probably moved on to something else. So our objectives for this tutorial will be to cover the essential RPC service descriptions, how to spin up our own servers and clients through HTTP, which is one of the core protocols that Finagle supports right out of the box, filters, and load balancers, which make services or distributed services very easy to spin up. As always, I recommend that you write code with me, and whenever you need to refresh your memory about these concepts or about the techniques that we're going to use in this video, just refer back to it or to the written form at the blog with the link in the description. All right. Now, without further ado, I have here in my IntelliJ IDEA, I have a simple application. I call this Finagle demo with a simple main that we're going to use to test some stuff. In my build SBT, I have just two libraries, Finagle Core and Finagle HTTP, with the version 22.7. This is the most recent version at the moment of this recording. Okay. Now, the core abstraction of Finagle is that of a service. A service, in theory, takes two type arguments, let's say A and B. A service is functionally equivalent to a function from A to a future of B. This is essentially what a service is. You pass in a value A, and you expect a value B in the future at some point, and you don't know how that future is computed or when it will be returned. That's it. Now, this future can be computed on your own JVM on the same machine through the regular thread pools and so on and so forth, but this future can be obtained by interacting with a remote system, which makes the Finagle library be an RPC, that is, remote procedure call library, because you use this function locally, but this future can be computed by talking to a different system. This is an RPC library, and this means that you can build distributed systems with this library, but invoke these functions as you would locally. This is what a service is, and you will find that this abstraction is immensely powerful. Let me define our first service. Let's say that we would like to define a service in terms of HTTP requests and responses. So these are the two types that we are going to pass in here. And I'm going to define a method, let's call this string length service. And this is going to be a new service with request, and this is from Twitter Finagle HTTP, and response, again, from Twitter Finagle HTTP. So this is an HTTP service. I'm going to import that as well. So new service with request and response. You pass in requests and you get responses back later. And the only method that this service thing has is called apply. So this is essentially a function from request to future response. And now the apply method, very importantly, returns a future of response. Now, very importantly, this future is not the same as that in Scala util or Scala concurrent, if I remember correctly. So this belongs to com Twitter util, which is what we need to import. So it's not this one that we normally use in Scala, but it's this one from Twitter util. Futures in Twitter util are very similar to that in Scala concurrent, so they operate in the same way. They have very similar transformers. They have map, flat map, and for comprehensions, for instance, but they're managed differently by the Twitter internals. So we're going to use this type instead. Okay, so notice that this service only has the apply method, which makes this service equivalent to the function request to future response, and we're going to build a future. So future exactly like this. Future apply method, much like we do on regular futures in Scala concurrent. And I'm going to define, let's call this input as request dot. So this is the HTTP request. And let's say that we would like to send GET requests at localhost 9090. And I'm going to pass in a query parameter, let's say name equals Daniel. And I would like to return the number of characters in this query parameter, let's say. So I'm going to say input is request get param with the name. So this is the name of the query parameter. And I'm going to say val response, and I'm going to build an HTTP response. So this is simply kind of like a case class. So you can use the apply method. So response, I'm going to say status from, and I'm going to use from com Twitter Finagle. And I'm going to say status.ok. Or should I use from HTTP, I think. Let's use the one from HTTP. Okay, so status.ok, this is the right type. Cool. And at this point, I can then pass in some contents. So I'm going to say response dot set content string. So this response data structure is mutable. I'm going to say input length dot to string. So I'm going to do the computation and store that in the response payload. And then I'm going to return the response here as the result of this feature. All right. So this string length service is a new service where you can pass in an HTTP request and you get a future of HTTP response built in this way. So nothing rocket science so far. Now, you can instantiate the service as an HTTP server. So I'm going to say, let's call this simple HTTP server. And I'm going to implement that as HTTP written as this. So I'm going to import that from com Twitter Finagle. Okay, so I'm going to say http.serve. And you can pass in the address at which you want to serve. So I'm going to say serve at, and I'm going to use colon 9090. So this is localhost 9090. And I'm going to instantiate this string length service as the engine for that HTTP server. So this is string length service. Okay. Now in main, I'm going to call this simple HTTP server with a construct called await.ready. So await.ready with this simple HTTP server. This will essentially wait for the internals of this HTTP servers to start their thread pools and so on and so forth, and keep it alive forever. All right, now what I can do is I can start my application and spin up my first HTTP server with Finagle. Let's see. So now at this point, we have our first HTTP server, which is alive. Now I would like to start up a terminal. So I'm going to go here and add a terminal here. All right. And I'm going to issue my first HTTP request. I can use curl or any kind of command line tool. I'm going to use a tool called httpy, which has this command http. So I'm going to say http get at localhost 9090, and I'm going to use question mark, and I'm going to say name equals Daniel. And this should give me back an HTTP 200 OK, so this is the status, with the length of the string Daniel, which is 6. All right, let's see. So we have an HTTP 200 OK, and the payload is the number 6. So my HTTP server works nicely. If I pass in something else, name equals whatever, I'm going to get the content 0, and so on and so forth. If I have no parameter, this will give me an internal server error because the parameter is non-existent, and here I have my first stack trace, so I haven't handled that query parameter. Of course, you can add any sort of checks to the logic of the service, of course. So because the getParam thing throws a null pointer exception if the parameter is not there, obviously you can wrap this in an option. So I can say option request getParam name, and I can say map underscore length, and then I can use getURLs -1, for instance, and -1 meaning that the name query parameter is not there. So this is going to be my, let's call this computation result. Now I don't really need the length here. I only need to convert that to a string. So now we've added some null pointer checks with this option data structure, and obviously I can issue the same kind of request, and now I can get the -1 as expected, and with the query parameter Daniel, I'm going to get the correct result as before. So there are some checks or safety that you can add to the internal logic of your services, but that's not necessarily the goal of this demonstration. But the goal was for you to see how easy it is to define services with Finagle and just start them as HTTP servers. Now, obviously, you can pass these sort of HTTP requests also programmatically. So let me create a new application. I'm going to call this object, let's call this simple client, with a main method. So I'm going to spin this up as a separate application. I'm going to show you how you can interact with the existing HTTP server that is still active. So I'm going to define my client as a service from request to response as http.newService with the URL, like localhost 9090. And at this point, you can invoke this service locally. Of course, this service will internally talk to the other JVM, but you don't know that, or you don't really care about that, which makes Finagle a very powerful RPC library. So I can say val request as request with method.get, and I think method needs to be imported, so I'm going to use that. So method.get, and I'm going to add the URL, which is the question mark name equals Daniel, let's say. And I'm going to have my response as client invoked with the request. So notice how easy it is to just invoke the service on the HTTP request and you'll get the future of HTTP response. You don't care how that future is being served. It can be the entire rest of the world in terms of computational power, but you only need to care here at line 33 to just invoke a function. Now, this is going to be a future of response. Now, this future of response is an asynchronous API, meaning that you can add on complete callbacks, you can add for each, you can have transformations like map and flat map, and for comprehensions. And if you've seen futures in Scala concurrent, you know how to operate with these ones as well. For example, I can print the response once it's completed. So I can say response.forEach. And you can have a callback, which is going to be executed when that response is being fulfilled. So I'm going to say response. I'm going to print line response.get content string to just print its payload, for instance. Now, I'm also going to add a thread sleep because once I register this callback, the application, the main JVM, will not wait for the future to be completed. So I'm going to force it to wait a little bit. So I'm going to say thread sleep for a second, let's say. I'm going to start this application. Let's see what we get. So notice that we have the number 6, and obviously after a second we have terminated the JVM, and the Finagle demo HTTP server is still very much active. All right. So notice how easy it is to interact with other services, in this case HTTP services. Now, Finagle at its core is protocol agnostic because the whole goal is to be able to just invoke your client or your service on your value, and you get a future of the computation result. You don't really care how that computation result was being served, and Twitter is fundamentally a distributed service. So it's really important to abstract away the fact that you might interact with a different system or a different JVM to get your value back. So this was the description of a service as well as HTTP servers and clients based on this API. HTTP is supported by default in Finagle, of course, with additional libraries in this mini ecosystem for routing HTTPs and so on and so forth. Okay, now I'm going to show you filters. A filter is essentially a function that can transform requests and responses to and from other data types. In other libraries in the Scala ecosystem, equivalent concept is middleware. So middleware is a piece of logic that can transform the incoming things into other types so that you can manage them more easily. And the diagram that I prepared for you, I have a very nice ASCII diagram in my little notes here. You can think of a filter as this sort of little box that sits in front of a service that can massage the input requests into the kind of data structures that the services can handle. So a filter is essentially composed of two functions. One that turns this rec_in into rep_out, and another function that turns the rec_out into rep_in, and these two are the ones that the exterior, the outside world, will know about, and the internal service will deal with just the massaged data. So the filter, so let's say filter input, is a function rec_in to rep_out. Then you have the actual service, which is rep_out to rec_out, and then filter output is rec_out to rep_in. And this sort of function composition is defined as the filter data structure, which has rec_in, rep_out, rec_out, and rep_in in the order in which this data flows as the type arguments of this filter. And the filter has one method, is called apply, that takes a request as rec_in and a service, which is a service of rep out and rec out, which is the data type of the service itself. And you'll get a future of rec out. So the entire structure that you see in this absolutely fabulous ASCII diagram is encapsulated in this one function signature. Now, it's sometimes very useful to add filters in front of the services with the same request and response types, which is why we also have the type simple filter with just request and response. And this is the same as filter with rec in and rec out being equal, and rep out and rep in being equal. So we have rec, rep, rec, rep. Now, let me show you an example. I'm going to define a small class. I'm going to say timeout filter with request and response. I'm going to add some arguments here. Let's say timeout as duration, and the duration is going to be imported from com_twitter_util, and a timer as timer, and this is going to be, I think it's called com_twitter_util timer. Okay. And this extends simple filter with request and response. And I'm going to override the apply method. So override the, okay, I need to import simple filter so that I know what to override. Override apply. This is it. Request and service. Notice that it matches the function signature here at line 54 in my explanation. So we have a request and a service, and we will get a future of response. Okay. Now, I would like this timeout filter to issue a future that throws an exception if it's not being served within this timeout. So I'm going to say service apply to request, which is a future of response already. And I'm going to decorate this future with a combinator called within. So within will return a failed future if it's not being completed within this timer and duration. So I'm going to pass in my timer and timeout as arguments. So you can add these sort of extra logic to the existing logic of a service. Maybe you would want to add extra checks, or maybe you want to add extra requirements or data massaging, depending on what your objective is. Now, let me show you how you can add this filter in front of the client just to show you how easy that is. Now, I'm going to call this original client because I'm going to decorate it with my filter. Let's say timeout filter as new timeout filter with request and response. I need to add the type arguments. And I'm going to add a restriction for, let's say, 1 second, and the timer I'm going to build Java timer. So I'm going to use duration dot from seconds 1, and the timer is going to be a new Java timer, I think. Java timer with, and I think it has a flag is daemon, and I'm going to use false. So I'm going to use new Java timer exactly as it is. Okay. Now I'm going to decorate this original client to obtain a filtered client as timeout filter and then original client. Notice how easy you can chain these two to obtain a new service. So you can consider the combination of filter and service to be one giant service that you can interact with. So this filtered client, I'm going to pass it here. So filter client applied to request. And let's also modify our HTTP string length service to also take a little bit of time to compute. So let's say I'm going to do a thread sleep for, let's say, 1200 milliseconds. And I'm going to wait for 2 seconds in my main application. So I'm going to navigate back to my server and start again. All right. Okay, and here in my simple client, because my future is going to be failed, the for each thing will probably not print anything. So I'm going to say on success. And if I get a response, I'm going to print it out. I'm going to use response.onFailure. I'm going to use my exception. I'm going to say exception print stack trace, let's say. And let me start my simple client over again. Let's see. So after 1.2 seconds, the filter has failed and we have a stack trace. So we have a timeout exception because the filter was successful in blocking my response here. So the future was filtered and my stack trace was being printed to the console. All right, so far we have the description of services. We have HTTP clients and servers. Now we showed filters. One last thing that I wanted to show you is load balancers. Now let me collapse my little consoles there. So load balancers are a powerful built-in feature of Finagle that will allow us to interact through the same service with multiple backends at the same time. Of course, through a load balancing scheme. And the requests that we're going to pass through the service, we are going to automatically forward them to all the instances that we're going to use in our load balancers. I'm going to give you an example by first modifying my Finagle demo server to spin up multiple HTTP servers at multiple ports. So let me add a bunch of modifications to my code. I'm going to have a port here as an integer. I'm going to modify that. So I'm going to say port here. And instead of a single await ready, I'm going to spin up a bunch of ports like 9090 to 9092, let's say. So I'm going to spin up 3 servers. So I'm going to say map, and for every port, I'm going to say simple HTTP server at that port. And then I'm going to say for each, and for each, I'm going to say await ready. So I'm going to say for each await ready, and I'm going to spin up 3 servers at the same time. Now, just to illustrate where each request comes into every one of these services, I'm going to also give you a filter that you can put in front of a server. So in the same way as you can build a filter in front of a service while interacting with a client, you can put a filter in front of a service by encapsulating them both as an HTTP service. So I'm going to give you a, let's say, a debug filter. I'm also going to pass in a port or an ID, let's say ID as a string. And I'm going to use a new simple filter. I'm going to implement that right out of the box. I'm going to have request and response, and the override method is apply. And I'm going to simply serve this request through the service, but I'm also going to add a debug string. So I'm going to say print line. I'm going to add in a small tag with my ID, and I'm going to say received request, and I'm going to inject request inside, and I'm going to simply serve that through the service. So service apply to request. Okay, not server, but service. Okay. Now this debug filter I'm going to put in front of this string length service. So I'm going to say debug filter with the ID, let's say server dash, and I'm going to use port here for lack of a better idea, and then the string length service. All right, now at this point I can start up my new JVM, which should start 3 different services, but I have a compiler error, which is the awaitable here at line 35 with the await ready. I think I need to write an explicit lambda over here. I'm going to say server, and I'm going to say await ready server. I think the explicit lambda should solve this. Okay, so now we have 3 different services. Okay, good. Now at this point, I want to show you something more manual before I can show you a client that will interact with all these services at once, just to prove that all of them are alive. So here in my terminal, I'm going to issue some requests with 9090. So I'm going to get the result 6. I'm going to say 9091, again 6, 9092 request, and I'm going to have the same value. 9093 should give me back an error. So we don't have an HTTP server at this endpoint. Okay, good. So all my services are live. Now, I would like to interact with all these services at once through a load balancer. So I'm going to copy most of this stuff, and I'm going to call this load balanced client. And I'm going to, I think I'm going to remove everything. So I'm going to start from scratch. I'm first of all going to write the addresses for this. So addresses are going to be 9090 to 9092. And then I'm going to say to list map. And for every port, I'm going to return an address with a host in a port. So address from column Twitter Finagle. And I'm going to use localhost and port. So this is a list of addresses. Then I'm going to create a data structure called a name, which will identify all of these under the same name. So I'm going to have, let's call this name, which is a name of the capital N. And the name is a data structure. I'm going to say name bound with a bunch of addresses. And this is a var arg method. So I'm going to say addresses. And because we're using Scala 2, I'm going to expand that with this syntax, underscore star. In the Scala 3, you'll simply put a star at the end, much like Python, okay? And I'm going to have my client as HTTP new service. And instead of doing localhost 9090 as I did before, I'm going to bind this name. So I'm going to say name, and I'm going to give it a label. I'm going to call this simple client. The name is the label here is not that important. And now I'm going to create a bunch of requests. So I'm going to say val requests. I'm going to say 1 to 20. I'm going to issue 20 requests, and I'm going to say map for every I. I'm going to have request with method get with a capital G. And I'm going to say question mark name equals. And I'm going to inject some expression here. I'm going to run the string, let's say, Daniel times I. So this will simply repeat the string Daniel I times, if I remember correctly. So this just repeats the string n times. Okay. So every request is different. Now, I'm going to obtain a bunch of responses. So responses. Of course, I'm going to say requests map. And I'm going to have my client apply to the request. So request map client. Of course, I'm going to say request client request to make this more explicit. And this is going to be a list of futures. So this is going to be a sequence of future response. Now you can collapse these together with a concept that in pure functional Scala goes by the name of traverse, but the more sensible name is collect here. So I'm going to use future.collect. And future.collect is going to turn the responses into a single future storing all the responses together. So I'm going to say dot for each print line. And then I'm going to do a thread sleep. I'm going to sleep for 5 seconds, for instance. Now, just to show you how those requests are being received in the servers, if you remember earlier, a couple of minutes ago, we issued a bunch of manual requests in the terminal, and these show up in my server logs. So server 9090, 9091, 9092. So we have request get, and we also have the query parameter here, which is very useful for us to debug which requests came from which server. This is interesting. Okay, let's try my load balance client. So in this case, we should be issuing 20 requests, and we have an array sequence with responses. So we have status, status 200, status 200. This is not really that useful. We should have simply printed every single content string. So I can do a map again, and I can use underscore get content string or something like that. So requests, map, request, client request, and I can use map in here. And that's because the get content string belongs to the response, which is of the future with client request. Anyway, let's check out the logs in the server. Now, at this point, we now have a bunch of requests in the server. And notice that the requests are being issued asynchronously, so they may interleave here. So notice that we have a bunch of requests at server 9090, a bunch of requests at server 9091, a bunch of requests at server 9092, and so on and so forth. So notice that this client here, the HTTP new service, will simply redistribute all the requests to all the services bound at this address. This is very important because load balancing is now transparent for us. This is exceptionally powerful because if you ever need to scale a service, you only need to spin up a new machine, add it to this address, and boom, you have the same functionality. This is exceptionally important. And the load balancing strategies can be inspected in the Finagle documentation. I won't go into load balancing strategies too deeply here, but even the fact that there is such a thing as load balancing with such an easy API is pretty mind-boggling, and this shows the effectiveness of this kind of library for such a distributed service as Twitter. Now, if we run the load balance client one more time just to see the values here, we're going to obtain the same results as before, obviously with a right content string. So 6, 12, 18, 24, and so on and so forth, multiples of 6 because Daniel is 6 characters. And we're also going to get a new set of requests to our endpoints. This is powerful. So I hope this video was useful in showing you how powerful the Finagle API is. It offers APIs for both Java and Scala. If you want to check them out, I'm going to link a documentation link in the description. So if you like this video, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn. I post fresh updates on upcoming material. And check out the Rock the JVM website. I have literally hundreds of hours of everything in the Scala ecosystem. Until next time, folks, I'm Daniel, signing off.